software. So I'm sure every one of you would have downloaded the latest version of Packet Tracer from your NetAcad. All of you have the access to NetAcad portal since you all have completed the Python programming course in the last semester or the previous semester. So you must have a seamless access to NetAcad portal. If you have not, I encourage every one of you to download this one at the earliest and then install in your laptop. All right. So today's session, it is my duty to take a tour of this Packet Tracer software. So for that, let me share the screen. I have with me Dr. Jasper Catherine ma'am joined as one of the panelists, Dr. Getsi Jaba as the co-host and panelist for this session. I'm also having Dr. Daniel Madan Raja as the panelist and Dr. Devapriya as the panelist. So they also will be able to assist you then and there, maybe taking attendance shortly, or maybe enabling the poll or asking some quick questions to respond, all these things. Is that fine? So you have a chat box at the right hand side on the screen. So that can be used by you if you want to send any message to the panelist. So you can send a response. In case I put a question, you can send a response to every one of us in the chat box itself. So before proceeding, let me share the screen, and I request my co-host and the panelists to let me know if there is any technical glitch. All right. So I have shared the Packet Tracer software to you. Hope this is all visible. Co-host and the panelists, can you confirm?
Yes, sir. It is visible.
All right. Thank you. So let's proceed. This is the Packet Tracer software you all are going to enjoy this semester and in the further semesters. Very, very handy tool, which will certainly help you to learn computer networks in a very, very detailed way. So I encourage every one of you to install this instead of having any other gaming software. You can have lot of fun things available in this particular tool. Right. So as we are progressing, we are going to explore a lot about this tool. But for today's session, I just wanted to explain to you or help you in understanding the basic configurations, how to bring in a device, how am I going to connect those devices, how can I assign IP address, and then how they are able to communicate, can I visualize what is exactly happening, and so on. Probably this session will certainly help you to understand all these things. All right, in this Packet Tracer tool, on the left hand side bottom, you can see multiple devices available. All right, they are called as the intermediate devices or the network devices. Then you call it end devices, and then moving on, the other components and the connectors and multiple other things as well. So generally, a network will consist of three major things. When you talk in terms of hardware, they are the end devices, the intermediary devices, and the cables or the connectors. It could be wired sometimes, it could be wireless as well. All right, some media or medium which helps connecting these devices. So these are the three major components of a network. So as you are progressing, I'm going to bring one or two end devices and one intermediary device and some connections among them, and we are going to visualize how it works. So for that, any network is supposed to have at least two end devices. All right, for that, I click this button. You could see on screen, in the end device button I'm clicking, and on the right hand side you could see what are all the end devices available in this Packet Tracer tool. All right, at least some 10 plus tools devices are available. So I choose the PC. All right, I click this and then click in the workspace again. Probably I can increase the size as well. Yeah, this is somewhat more clear. So I have brought in one computer. As I have said, we need at least two computers or two devices as the end device. So I go for another computer. I click here and I paste here. So I have brought in two end devices to the workspace, right? And to connect them, of course, I can use a cable to directly connect them. What if I bring another computer here? So there are three personal computers which are named as PC0, PC1 and PC2. You can rename them if you want, probably CSC1. Just for our understanding, probably you can give another name here, CSC2, and then let's say CSC3. Right? So I have got 3 computers. I have given them a name. Please remember, this name has no importance in the network operation. This is only for our understanding, right? And I have brought in the end devices, right? And let me bring an intermediary device. For that, I click this network devices icon and I choose one of the devices. You could see router, you could see switch, and you also could see hub. So initially, let me choose this hub because it is very simple for us to understand. So I place a hub here. Probably I can't call it as hub because we are going to use only one hub, right? And what next? Can you respond in the chat box? What do you exactly need after this? I have brought in N devices. I have brought in an intermediate device. What is the third one we need? Can you look at the chat box? Are you getting any response in the chat box?
Yes, sir. They have responded as cables.
Server, yes, server, Joseph. Connectors, excellent. Connectors, cable, great. Cable wires, Stephen, yes. Few more responses. Okay, cables, cable, excellent. Connectors, all right. You have heard it correctly. So we can call simply as, no, instead of calling them as a cable or connectors, we can simply call it as a media, all right? And we are going to talk about a wired medium here. So for taking this medium inside, you could see probably a red and orange mixed color, right? Left hand side bottom, you could see, and that is the icon available in Packet Tracer to to highlight the connector. So I just click this. You could see multiple different cables available here, right? Because we are not sure which kind of cable I can use, because you speak about, for instance, console cable, you have got straight through cable, you got crossover, fiber optics, and cable for RJ45, coaxial, DC, DTE, and a lot of other things, right? Because we are not sure which kind of cable we can use. For the time being, we are going to use automatically choose connection type. So I click this, right? And I'm clicking on one of the devices and the next device. Once this connection is made, if I have chosen the correct cable and if the physical connection is correct, you can see a green color notification here. If not, it would be generally in red color, right? So this is perfect. And I'm choosing the cable again and I'm connecting. Which device am I going to click first? Which device am I going to click next is immaterial, because it is only a physical connection. So it does not talk about the direction in which the packet is traveling. All right, now what has happened? I have brought in 3 end devices. I have brought in one intermediate device called hub. There are few other intermediate devices as well. Probably router is an intermediate device. Switch is another intermediate device. All right, but these laptops and the personal computers are end devices. They are not intermediate devices. Is that okay? Now, I have connected these 3 machines to the hub. All right, and I could see there is a green color indication, maybe a light, I could say, and it informs that the connection is perfect. At least the physical connection is perfect. What could be the next one? Yes, we need to assign IP address to them. All right, at least 2 sections you are learning about IP addresses now, but I understand the rest of the classes, the batches, they are yet to speak about IP addresses. So I'm not going to spend a lot of time in explaining this, but I will just touch and go how to assign IP address. So in Packet Tracer, in network, computer networks for that matter, you require IP addresses for communication. All right. So what am I going to do? We are going to assign IP address to the end devices. Generally, for the hub we don't assign any IP address. All right. So I go and click this computer, and you could see a small window popping up. All right. So, and the third tab in that is desktop. Of course, there are more ways to assign IP address, but I'm talking to in a very the basic one. And in the desktop, you have the first icon or the app, I would say, is IP configuration. I just click and it asks about IP address. We are speaking about IPv4 address. So we are not going to IPv6 for the time being. In IPv4 address, I'm going to give the first very famous class C IP address. So 192.168.1.1. I just give 192.168.1.1 as the IP address. Then I press tab key in my keyboard and you could see the subnet mask is filled in automatically. Those who have learned about this can understand this is a class C IP address and its default mask is 255.255.255.0. All right. I need not press any OK or save approve button. I can simply close it. Then I go to another computer. I'm going to do a similar way. Click this, go to the desktop. I click IP configuration and I'm going to give an IP address here 192.168.1.2. I'm giving. Don't bother. Why should I give 1.1.1.2? What is this IP all about? You have some time to learn about them in detail. And it also has got its default subnet mask filled in. Go to the third computer. I'm clicking desktop, IP configuration. I give the third IP 192.168.1.3 and having the default mask. All right. Now we have got 3 machines connected to an intermediate device called hub, and we also have assigned them the IP address. So I just bring the mouse cursor over one of the icons. You could see a small screen popping up. It tells what is the IP address I have assigned. Did you see that? Yes. If you see on the screen, the 4th row, fast Ethernet link is up, and it has got the IP address 192.168.1.1. and it has got /24 notation, which is the subnet mask. You can cross check in Packet Tracer in a very similar way. It has got 1.2 and it has got 192.168.1.3. So all set, all these 3 devices are given the IP addresses. All right. Now we are going to check, are they connected properly? All right. So for that, I can do multiple things. I go to the same personal computer and there is a button called command prompt. So I click command prompt. This command prompt simulates the command CMD or the command prompt in your Windows operating system. All right. So I have got the command prompt here. I'm just going to send a message ping. Probably you have used this ping command in your first laboratory exercise of computer networks. All right. So ping command, ping, I'm going to issue the network address, the IP address of another machine. So 192.168, I say 1.2. I press enter and it says it is pinging and the reply is also received. And it says the statistics, all 4 messages have been sent, all the 4 have got its response. So loss is 0%, which means all the 4 packets have got their response. It also gives you the TTL period and so on. I could see Angeline Jerusha raising your hand. Probably we'll have the question session after 2:40 or 2:35. Thank you. All right. Now it works. All right. Now, can we visualize this? Yes, we can visualize this. So I go to a mode called simulation. If you could see on the right hand side on the screen, we got 2 things. One is real time, the other one is simulation. All right. So I go to this simulation mode. All right. So in the simulation mode, you could see lot of protocols available here. So we do not want all. So I'm just going to say show all or none. I click this again. All right. And I'm going to say edit filters. I'm going to just choose which protocol I want. And I'm going to choose ICMP. All right. And I close this. All right. So why should I keep my screen on? Okay. All right. Anyway, that's fine. It's okay. Right. So we have got three machines and we have moved to simulation mode. So we are in simulation mode. So I go to the same PC again, same command prompt. We have got 192.168.1.2 ping, same command I'm going to issue 192.168.1.2. I press enter. You could see here a small packet is getting ready. We'll have this also somewhere here. Yeah, somewhere here. This is sufficient. Okay. So you got a packet getting ready here, but as of now on screen, you don't get any response. This is called simulation mode in your packet tracer, where you can see step by step how these packets are traveling over the devices, over the network. All right. Now the packet is ready. I have not allowed this to go. So I just say go to the next step. This is called move forward. I say this packet moves to hub. All right. So the packet which you have sent has moved to hub. And you also have in packet tracer, you can open this packet and see what is exactly happening. But due to time constraint, I'm not going to do that. And I'm permitting you have to watch it carefully. You have to watch it carefully because I'm going to ask a question shortly. You could see what happens to this pink color packet. Could you see it has gone to both the devices? The packet was initiated from PC1, I'm sorry, CSC1. It has gone to the hub. From hub, this packet has gone to CSC2 as well as CSC3. Please understand, hub is a device which forwards the packet out of all interfaces than from the one it has received from. So it has sent the message to CSC2 as well as CSC3. This is how hub operates. All right. However, this packet is dropped here. The reason is the destination IP address does not match, and the destination MAC address also does not match. All right. But anyway, we can learn about this shortly. But this packet has reached CSC3, which is also accepted because you don't see any int mark. But you could int mark. You can't expect CSC2 to respond anymore. I'm going to allow this to still go further. You could see CSC3 sending a packet to hub. Now, I'm going to ask a question. You are going to respond in the chat box quickly. Keys on your keyboard. Where will the packet go? To the CSC1 or CSC2 or CSC1 and 2? Make it fast. Respond in the chat box. Only to CSC1 or only to CSC2 or CS1 and 2? Okay, good. I'm getting responses. All right. Okay, 1 and 2, both, 1 alone. Okay, CSC1, good, 1 and 2, I'm getting 1, only to 1, yes, okay, 1. All right, fine. Thanks for your response. Appreciations to everyone who have taken part in the poll in the chat box. Yes, thank you. Now you could see this packet is standing here, and we all have responded. Some of you have said only 1, some of you have said only 2, some of you have said 1 and 2. So we just click this button and see where it goes. Yes, it goes to both the devices. Please remember, I have already said this hub is a device which forwards the packet out of all interfaces except the one it has received from. All right, so this reply was initiated by CSC3. It has gone to hub. As the hub, it has to forward here as well as here. However, CSC2 is not involved in this configuration, so it simply rejects this packet. All right, only this person has received the packet. So can we see whether the response has come? Yeah, now the first reply has come. You could see initially the packet was coming out of CSC1. It has gone to hub. It has gone to CSC2, which was not accepted. It was also sent to CSC3. It was accepted. Then the response came, sent to both the direction. It has gone to CSC1. So response has come. You got the reply. Okay. Now I'm going to say you can do it automatically, and you can see what's the response coming on screen. You got the response. Third time. Okay, go a little faster, little faster. All right, so you got the response, right? This is how a hub is working. All right, so you all were listening how this hub is working. Now it is also my duty to explain to you how switch is responding. But before going to the switch, I'm going to demonstrate you what is happening in the case of broadcast. At least I want the students who are in my class and Catherine Ma'am's class to respond to this question now. From CSC1, I want to send a broadcast message. So what should be the broadcast IP I should give? May I get the response? Anyone who knows the answer can respond. Excellent. You got 1255. Great. Thanks for the response. So I'm giving 192.168.1.255. Okay, I should go to the simulation mode. I'm sorry. I go to the simulation mode. All right, I have demonstrated you how to send ping message through this one. Now I'm going to demonstrate, is there any other way of sending the message? Please listen to this. You have got an icon here called add complex PDU. Okay, you can click this, all right, and click on one of the devices. Then you got a screen appearing. So I am attempting to create a complex PDU, right? I'm typing the destination address as 192.168.1. You all said the address should be, broadcast address should be 255. And I just give some sequence number, one short time, I just say 32. I say create PDU. I have created the PDU. Let's go one by one. Now this is a broadcast packet which is coming from this place to this place. All right. And what do you expect? This packet to go here as well as here. Shall we see that? Yes. Did you see that? Yes. Hub is the device which sends even a unicast packet to everyone. Now we are talking about a broadcast packet. So this broadcast packet goes to CSC2 as well as CSC3. All right. So now this packet goes to CSC2 as well as CSC3. Now you could see both of them have accepted. The reason is it is a broadcast message. When it is a broadcast message, whoever receives this would generally accept this. They also will send a response. All right. I'm going to allow this to go further. You could see something is happening which we haven't experienced it earlier. All right. This is called collision. This is very similar to two people talking over phone simultaneously, that neither of them can listen what the other person has been speaking or is speaking, right? You could see there is something burning, indicating that they are useless. They have collided each other. That is useless. So let's allow this to go further. What's happening? Still, it is not going to help you anyway. So we are going to allow, and of course, so you cannot get, you can see on the screen, it says it is failed because there is a collision which has happened among the packet. All right. So this is how a hub is responding. So just to summarize the behavior of hub is just acting as a very similar to a repeater. If you're sending something from CSC1, it can be sent to CSC2 as well as CSC3. When CSC2 is sending a message to anyone, it will send to both of the people. When they are responding, again, it will go to both the people. All right. Whether it is a unicast packet or it's a broadcast packet, this is how hub is responding. All right. So I'm going to remove this hub from this and I'm going to bring a switch inside. All right. So for that, I have a delete button. I think it's here. This is the delete button. Yes. I click that. I remove this. Do you want to delete hub? Delete this. So the hub is no more available in the workspace. So I'm going to bring in a switch. Right. So for that, I go to this network devices again. I click switch. On the right hand side, you could see there is something called PT switch or switch PT. For the time being, you can choose that and you can bring here. And you can also rename that as switch. All right. Everything else remains same. So I'm going to this connectors. I press the control key and then press the connector so that I can use the same thing multiple times. All right. You could see on screen, if you have listened properly, you could see an amber color indication light. Whereas earlier in the hub, it was by default, it became green. But here you have got this in amber color. All right. It will take some time to become green. But in Packet Tracer, you can do a shortcut. You can simply click these two, 3 times. It will become green color. All right. Now this becomes okay. So shall we attempt the same thing whether CSC1 is having a packet? Yes, it is having the IP address 192.168.1.1. It is having IP address 192.168.1.3. It is having IP address obviously 192.168.1.2. All right, so I go to the simulation mode, very similar to the previous one, and I create a simple PDU, not complex PDU. I create a simple PDU. It is very similar to pinging. It is very similar to issue a ping command in your command prompt. The same thing. All right, I click this and I allow this to go. It is going. Now, can you respond in the chat box? What do you want or what do you expect to happen? This packet will reach CSC2 and 3, or CSC2 alone, or CSC3 alone, or nothing. It will be sent back. There are 4 options. Can you put it in the chat box? 4 options. CSC3 alone. Okay. CSC3, 3 alone. CSC2, good. Okay, 3. CSC2, 2. Yes, 3. 2 and 3. I think I saw at least one answer, 2 and 3. Okay. 3, CSC2. All right. Fine. Good attempt. All right. Go ahead. All right. So let's click and find out what's the response. It goes to CSC2 because I sent a ping message from this machine to this machine. So hub was earlier sending it to CSC3 and 2, if you remember that scenario properly. But now being a switch, it forwards only to this person. All right. Now this is the first difference you can get between hub and switch. Hub used to forward the packet out of all other interfaces or all interfaces than the interface from which it received the packet. But however, switch, it forwards the actual person. Let's allow this to continue. That's okay. Comes back. You can see the status as successful, which means it is done. And we also need to check another thing. What was that? I'm going to create a complex PDU. Click this, and the destination IP, I'm going to give a broadcast IP 192.168.1.255, and source IP it will take by default. Sequence number some 40. Okay, so this can be some 35. Some random number I'm giving less than 100. That's easy. I say create PDU. This is a broadcast message, and I'm going to say go. It goes. And can you quickly tell what will come now again? Is it 2 to 3, 2 and 3, 2 alone, 3 alone? It's a broadcast packet. 2 and 3. Kritika has the 2 and 3. Yes, Paul Emmanuel, many. Yes, Angeline, Grace. I'm reading quickly the names. Akash. Okay. All right. All right. Because being a broadcast message, you all have guessed it correctly, except 1 or 2. It is going to be a broadcast message. And you could see it is getting ready to send, but this is idle. And you can still see what was happening earlier in the case of hub. They both attempted and they sent at the same time, and there was a collision. Now here, this packet goes, no collision, it reaches safely. Then the next person sends, it reaches safely. You got it? This is the difference between the hub and the switch. Of course, there is a lot more to speak, but basically, this is the difference you can see between hub and switch. You all have understood what exactly is happening here. All right. So before I hand over the session to other 4 faculty members for any further announcements, I just thought of bringing the device called router also on screen. I'm going to choose a packet tracer router. I'm clicking here. So this is a router. All right. So this router, I'm going to click open. All right. Just do not worry if you are not able to understand fully, but I go to this config tab. Okay, device is still booting. All right. I go to the real time mode. I go to this. Okay, I'll wait. It is still booting. Okay. All right. So I go to this config tab. You can see this router. This is the physical mode. Generally, a router will look like. So I increase. Okay, zoom in. Can I still do it? Oh, this is what. So these are all various interfaces. We are going to learn about them, but I'll take only these 2 interfaces. I have already said in the class, your faculty also would have said, Routers are used to connect to different networks. Okay, so I'm going to talk about these two interfaces. I go to this config tab, choose fast Ethernet 00. Don't worry if you don't understand, but let's start at least. I switch on the port. I give the IP address 192.168.1.1 and the mask is 255.255.255.0. This is one of the interfaces of the router. Same router, I go to another interface and I'm going to attempt the same IP 192.168.1.1 and I press tab. It says it is overlapping with other interface. It cannot be assigned because these two IP addresses are belonging to same network. So I should give some other IP 2.1 or something. Then it will accept. All right. Anyway, we are not going to learn a lot about the routers now because we have learned about the hub and the switch now. Is that okay? So I think I'll stop sharing the screen now. We'll quickly take a poll. Let me check whether poll is available here. Yes, there is a poll available. So where is it? Okay, I have opened a poll now. The time says 5 minutes you have, but no, I'm going to stop it in 1 minute. You got 20 minutes more. 20 seconds. I'm sorry. 20 seconds more. Getsimam, probably you can stop recording.